Hello everyone. In this video, we're going to talk about how to take the URDF we created in the previous video and make it move in a simulation platform like Gazebo. This we're going to do using a framework called ROS2 control and more specifically bicycle steering controller. As you can see here, this is the ROS2 control page and I'm looking at bicycle steering controller. It's one of the controller implemented in ROS2 which we are going to use. As you can see, this perfectly applies for our case where we want to simulate a two-wheeler, and then a two-wheeler has like one wheel which is like the driving and the other one which is for steering. And as you can see, this two has the same two features which we need. Apart from that, to make this work, we need to pass on some parameters. And you can see here wheelbase, which is the distance between front and rear wheel, and front wheel radius, rear wheel radius. These are the parameters we need to pass. So as you can see here, under the URDF package, we can see here there is the xp controller.yaml. You have to create a config directory inside this one and then create a YAML file. A YAML file is specifically designed for configurations so that we can load it onto the controller. So for the YAML file, you would define what the controller manager is. Like you would define the controller manager, you would define the update rate, and then you would define the two basic things which you'd be using. One is the joint state broadcaster, and then the other one is the controller, which is the bicycle steering controller. And like we discussed, we would give all the parameters which we need. The wheelbase, the front wheel radius, rear wheel radius, and all the other things. And then here, when it asks for rear wheel names, you gotta give the joint which controls the rear wheel. And then for the front wheel name, you gotta give the joint which controls the steering. And apart from that, you gotta give the base link, which is like the root link for this robot. And also like you need to give the twist covariance and post covariance. I'm not going to dive deep into this, but you can use the default value to start off. Once this is set up, the next thing what you would have to do is to go ahead and modify your URDF file. So things you would modify is only so much. That is, you already have the URDF. You would add these things at the end of the URDF. So what are those? One is the plugin called Gazebo ROS2 control Gazebo system. This is basically used to convert the simulation joints into like an actual joints, like as if it was coming from a real robot. And the other plugin is libgazebo ROS2 control.so, and this one is used to load your controller file, the config file which you develop. So a little bit deeper, here we do like we define ROS2 control name and the plugin, and then here you give in the joint name. This is the joint which you would use to steer. So for this, the commanding interface this is where you would be like controlling using the controller, and so that's the command interface. And then you give the position, and the state interface is also push. State interface is used to get the value from the simulation and use it to command. And similarly, for the rear wheel, you would have to specify the joint which is controlling the drive wheel, and then here the command interface would be the velocity. So we would be more interested in like how fast, like more interested in commanding the velocity of the drive wheel. And to do that, we would basically need what the velocity is and what the position is to make sure that we reach the velocity needed. So here we close off ROS2, and then here we open the Gazebo, um, and then here we declare the plugin, which is libgazebo ROS2, and here the major parameters are one is the controller. So here you're going to say where you can find the config file, which defines about the controller. And the next one, what we're going to say is like which node can you look into to find the URDF, and that is loaded in robot param node. Be very careful with this name because this is exactly where it's going to search for the URDF. Now that we're done with the URDF and the controller file, what we have to work on is the launch file so that we can launch everything together. So first off, I want to start off with the URDF Cone Express Visualize. This I had described in the previous video, but one thing I want to reinstate is that this name, as you can see, is name my robot state publisher node, and this is the exact same name you would give under the robot param node. So that's very important. What I wanted to re-emphasize here. So with respect to URDFC controller launch.py, main things are we're going to launch these three nodes. One is the controller ROS2 control node, and the next one is the spawner, and then again this one is also a spawner, but here you spawn with a different argument. In order to do this, what you first need is the path to the controller configuration, which you can see here. That's what we're doing here. And then once we have the path, we use it in this control node remap. So this basically you use the package called controller manager and you use the executable ROS2 control node. And the parameters are the configuration file, and then you do a remapping here. This remapping is done because when you launch this node, the topics it's going to publish to are its own robot description topics. So we don't want that. We want it to be the common robot description topic, so that it'll update ROS. And then the next one is it shouldn't like publish to bicycle steering control TF autometry, but it should publish to TF. So these are common remappings which would make the simulation work. And the spawn controller, you would run the spawner, but here you will use the argument as joint state broadcaster. This is important because this says what's the joint states of the robot. And then the next one is the same spawner but different argument, which is like bicycle steering controller. These are the two things which we need to get spawned, and this needs this one, so this has to be first, because based on the joint states this will give the command to control the bicycle. And then as like how you would launch in any other ROS tool, you given all these variables you defined here, and then so these will get launched. The next step, what we're going to do is to create a new package. So here we call it as Cocoon Express Gazebo. And this package, what we're going to do use predominantly is to maintain the Gazebo files. So what we are going to do is like first we create the world file. So you can see that you can just use this. This is like a plain world without any objects in it, just the sun, ground plane, and stuff like that. So first we do this. To launch the Gazebo, what we would need to do is to create the launch file, which has the path to the Gazebo ROS and also this package. So here what we intend to do is to have the models which are there inside this, and also the URDF package, which we can see here, which contains the Cocoon Express. We want to soft link that to where Gazebo looks to find all its data. So this portion is done explicitly to soft link all of these files so that it will not have a problem to look into that. And once we do that, what we do is to go ahead and launch Gazebo. So this is, in this way you give the path to launching Gazebo in its default way, and then in the return you just mention the world, what you declared here, and then this is the empty world, and then you give this to launch Gazebo. So once you launch Gazebo, the next thing is to launch your robot inside Gazebo. So this launch file is especially for doing that. You define where you want it to launch it, like where you want the robot to be spawned in the simulation. You give the position, orientation, and the name. And then you also give the entity name. This is to generate a multiple copies of the same and still not have a problem. And then you use the spawn robot, which is basically a node which is of this package, and then the executable spawn entity, and then in the arguments you give the robot description. Whatever is there already on the robot description, you use that, and then you use the orientation which you defined here to spawn that robot in Gazebo, and then you give spawn robot here. And finally, with all of these launch files, instead of launching each one of them one by one, you can just make up this .xml file and have a bunch of launch files in this, and then just launch this one. So you have the visualize, which is used to get the URDF up, and then you use this to get the controller up, and then this one to get the robot inside Gazebo. So with this, we have successfully defined all the launch files, all the controller necessary to simulate. Okay, so now we have done building the package. Let's actually build it on the software. So to do that, go inside your package, go inside your workspace, and then source it, setup.bash, and then do a callcon build. Once you build the workspace, next thing what you would do is source, and after you source it, you launch ROS to cxp gazebo start world cxp.launch. So when you give that, you can see that you have Gazebo come up, and then you open up another terminal, and then what you do is first you source it, and after you source it, you launch that XML file which launches everything for you. So launch that, and you can see your controllers being launched, like the bicycle steering controller and the joint state broadcaster. So these are like configured and activated. That means your controller would be working. And you can also see the Cocoon Express here. Next, in order to move it, what we do is we use ROS to topic and publish to this topic. And when we do that, you can see here that it starts to move. And it starts to move, and just as we have given it, so if we want to stop, we can just like click this, and then we stop publishing, it'll stop moving. And then again, if we publish it here, you can see like linear 0.01, and the angular is also 0.01, and then you can see that it starts to move again. So in this way, we can actually control the Cocoon Express using ROS2 bicycle steering controller. So that's it. That's how you would simulate any robot on Gazebo using ROS2 control. If you like the video, please like it and also subscribe to the channel to get weekly content which are related to robotics and help you grow more in robotics.